In this video, we're going to talk about a phenomenon called freezing point depression and boiling point elevation. So in the Northeast, you've probably seen something like this. This is called ice melt. You can buy it in grocery stores or home depot type stores. And we put it on our sidewalks and our driveways. And its job is to melt the ice, or it's actually probably better defined as it prevents ice from even forming. And it does this because of a phenomenon called freezing point depression. So if you put this on your driveway or your sidewalk, what happens is any of the snow that melts during the day turns into water. But at night, when the sun goes down and the temperatures drop, that water on your driveway or your sidewalk will freeze. But if it's mixed with something like salt, this is actually calcium chloride, and if it's mixed with an ionic substance, the freezing point goes down. That's why we say freezing point depression. So where water normally freezes at 0 degrees Celsius, temperatures that are quite easy to reach in winter at nighttime, if it is a mixture of water and this calcium chloride, it won't freeze until it reaches below 15 degrees Fahrenheit. So the freezing point depression is the lowering of a solvent's freezing point due to the addition of a solute. And it actually has an opposite effect on boiling point. So we have freezing point depression, but we also have boiling point elevation. Boiling point elevation is the raising of a solvent's boiling point due to the addition of a solute. So if you put salt in water and you boil it, water normally boils at 100 degrees Celsius. It actually won't boil at 100 if you have salt in it. It'll boil at something higher than that. So you see people putting salt in their pasta pots, and it's probably usually just to alter the taste. But it actually will take longer for a salted pot of water to boil than it would a plain tap water pot of water to boil. So there are example problems that I see many times on the Regents, and you can usually pick them out just by looking at your choices. And you're basically looking for an answer that's going to say the gist of freezing point depression, boiling point elevation. If you put salt in water, freezing point goes down, boiling point goes up. So let's look at this question here. What occurs when sodium chloride is added to water? And the answer is 1. The boiling point of the solution increases and the freezing point of the solution decreases. So that's boiling point elevation, freezing point depression. Here's another one. Compared to a 2 molar aqueous solution of sodium chloride at 1 atmosphere and a 3 molar aqueous solution of sodium chloride at 1 molar or at 1 atmosphere has what? Okay, so we have this number here. In the previous video, we talked about how this is a way to quantify concentration. So compared to a 2 molar, a 3 molar has what? So this 3 molar means it's more concentrated, it has a higher molarity of salt. So that is going to change the freezing point and the boiling point. So the more salt, the better that effect, that freezing point depression, boiling point elevation. So let's look at our choices here. The 3 molar aqueous solution of salt at 1 atmosphere has a lower boiling point and a higher freezing point. Does it have a lower boiling point and a lower freezing point? Does it have a higher boiling point and a higher freezing point, or a higher boiling point and a lower freezing point? Well, we can eliminate choices 2 and 3. It's not going to lower or raise both the boiling point and the freezing point. But if you can get that little saying in your head, freezing point depression, the freezing point goes down, boiling point elevation, the boiling point goes up, you'll see that that is answer 4. Higher boiling point elevation, lower freezing point depression. Okay, and one more here. How does the boiling point and freezing point of a solution of water and calcium chloride at standard pressure compare to the boiling point and freezing point of water at standard pressure? So I have a solution of water in an ionic substance, calcium chloride here. They want to know, how does the freezing point of that compare to the freezing point of standard water? Well, of course, when you add solute to any water, especially an ionic substance like calcium chloride, we're going to get that typical freezing point depression, boiling point elevation. And that, of course, is answer number 4. The freezing point is lower and the boiling point is the solution is higher. So in summary here, when you add solute to a solvent, the freezing point goes down. We call that freezing point depression. And when you add solute to a solvent, the boiling point goes up. We call that boiling point elevation. So to remember this, remember that phrase, freezing point depression, boiling point elevation, or just ask yourself, what do we do to our driveways in the winter? We put salt on them so they don't freeze as easily. The boiling point, the freezing point of the water in the driveway goes down. We put salt in our pasta pot so the boiling point goes up. It might take longer to boil, but the pasta will cook faster once it's at a boil because it's boiling at a higher temperature than it normally would. So that's freezing point depression and boiling point elevation. Almost always on the Regents every single year. Practice these questions, and if you have any questions, please let me know.